Okay, please go ahead.
Good noon, everyone. Thanks for coming. And today I'm gonna talk to you about my research. My name is Mauricio Gomez. I am studying in the College of Technology under the M2M lab, that is translated to machine or man-to-machine, kind of relationship between robots and everything. This is a research done about with other persons. One is my advisor, that is Eric Matson, and other lab mate, that is John Hawking, Korean as well. The topic is iterative learning system to intercept a ball for humanoid soccer player. And I will start with a kind of question, research question, that is how iterative learning can help humanoid robots to learn to intercept a ball. What is iterative learning? Well, iterative learning is just the process when a human being engages in the process on learning by doing. This concept of learning by doing, it is still implemented in the universities, where you learn by doing. So I was thinking, why robots cannot also learn by doing, or doing it in an iterative way? How can it be implemented in a soccer, humanoid soccer field? It is a good application for it. The agenda will include some background information, the challenges that are faced in this kind of research, what is our motivation, and some technical design of our solution, to finish showing you a little test and result, and to finish with a simple conclusion. So, I don't know if you have known about that around the world there already exists not only one, but several leagues for competition of humanoid robots, or for robots to compete to see who wins in soccer. So one of them is called RoboCup, and it is not RoboCup, it is RoboCup. It's the same, like the same, but it was started in 2002, and the ultimate goal of this initiative is that in 2050, the one team made completely out of humanoids will beat the one that wins the world championship in that year. I can tell you that it's a very ambitious goal, but I'm just telling you what it is. It's not my goal, it's the goal of this. And it's very ambitious, because we are now in 2015, right? And that means that we have 35 years to accomplish this kind of thing. I think it's a little small time, but who knows, maybe we can make it. In RoboCup, they have different leagues, where there is the standard platform, where now is called something like 4-legged robots. There is also the small size, middle size simulation, mixed reality competition, and humanoid. The one that I'm talking to you today is about human. So, as challenges for the humanoid league, we can tell that one of them is the balance technique, because when you, it is a humanoid it has the shape of a human, right? And it has the same problems that a human has to face or has to overcome during all his life. As they don't have a memory that can store everything that is for a human done in a learning first stages of life, like crawling and walking. So the steps we as human learn it by doing. Like first time we try and we fall down, and we wake up, we get up and continue trying, right? So the balance is one of the problems for this kind of thing, because I don't know if you, I can tell you, I'm really not good playing soccer. I try to, but I'm not good at it. So because I can tell you that last year, you didn't see me, but I got a sprained ankle, exactly playing soccer here in Zurich. So for a human, the balance is a problem. So for a humanoid, it's going to be maybe worse. Other problem is the vision, where you have, or the humanoid has to identify the teammates or the opponents, and also have to find the ball and drive it to the goal or to the score, to score. Also, we have a strategy that involves communication and teamwork, like offensive and defensive. Our motivation, as I have already told you a little bit, is like the majority of the teams that compete in this moment are just trying to find the ball and look for the goal and drive it over there. So they don't make any pass to each other. That is the way that it works. And so for our technical design, the goal is to teach Darwin to intercept a ball successfully. And the requirements are recognize the ball, predict the trajectory of the ball, and learn the steps, the number of steps that he has to make, like in a parallel way or lateral way to intercept the ball. The functions are ball recognition, trajectory prediction. We use a little knowledge base to store the learning steps that has been done, and motion generation. There is a little explanation of the trajectory prediction, and also the motion generation is very difficult because this robot is Darwin, and it has 23 motors. So each of the motors has to have the way that it has to move, and the motors are called servos. They have something that is called encoding. So in each of the steps, these are the number of steps for each of the movement that has to be done. So each of the motor has to be determined what is going to be the position. It is somehow difficult because also what I told you, that is the balance problem. I want to show you one little test that we did of our what? Yeah. So he says, well, because it was successful, right? And it looks funny, I know. But that is what our research is being done, and I try to explain a little quickly because of the time what was our research. So as a conclusion, the real environments for humanoids are very difficult to model, and the improvement of a ball recognition will increase successful ratio, because after we started making our test, we saw that the ball is now recognized by the color, but the vision that specifically Fuchen was explaining is a real problem in robots or in machines, because the color can be detected because of different light that is receiving is going to be different colors, so it is very difficult. Lots of trial and error are needed to make the robot intelligent, and iterative learning can be applied to robots for more precise in future attempts. that is my presentation for today. I don't know if you have any questions.